What's up, everybody? Welcome back to the channel. I am Christopher Beam with Tactical Advantage, and today we're going to talk about bullet setback, what it is, and what it means to you as a concealed carrier.
Henry Holsters is one of our trusted holster providers at Active Self-Protection. From the Enigma Easy button to their light-bearing Ember, their ambidextrous Cypher, and their AIWB or IWB Spark and more, they make high-quality holsters for many popular firearms. Go check them out at the link in the description.
Okay, folks, so today I'd like to talk a little bit about bullet setback, what it is, what it means, how it impacts the ammunition that may be in your gun right now that you use for protection, and just kind of go a little deeper than what I've seen online people talk about. People talk about it being an issue, but they don't really talk about the why. So what I thought I would do today is talk through it a little bit and then do a little experiment to see how it impacts ammunition. So first things first, bullet setback is really about the projectile in a metallic cartridge being pushed in to the case by repeated chamberings or chambering alone. Basically applying force to the projectile, which is then pushing it into the case. So what I've got is a little bit of math here, some measurements with 9mm because that's the most prevalent concealed carry case out there. So that's what I decided to use. So first off, what we have here is a beautiful diagram, if I do say so myself, very artistic, of a 9mm cartridge. And the normal maximum COAL, or cartridge overall length for 9mm, is 1.169. So that's really driven by the length of the chamber and the barrel relationship of lands and grooves. So how long can the cartridge be to still be considered a 9mm or 9mm Luger? And the next one is I have the length out of one of my manuals for a jacketed hollow point in 115 grain. And that overall length is 1.05. So you'll notice these are being measured out into the hundredths, sometimes into the thousandths of an inch, and it's relatively impactful. So that's what we have right now, that 1.05 and the 1.169. So I think we should talk a little bit about how ammunition really kind of works. And there's a couple things that govern this in thermodynamics. One of them being Boyle's law, which talks about how gases and pressure relates to volume in a given container, for the lack of a better way to put it. Try and keep it relatively not complex, but that relationship directly dictates how fast pressure builds, how much pressure builds, and how things act underneath rapid combustion. Next would be the kinetic molecular theory of gases. And this is how gas acts on a molecular level as it's being combusted, and what those things do, how it happens. Now, that's a whole different rabbit hole that one can go down, but I figured I'd put it in here if anyone really wanted to look into it. I know that's a very small niche segment of the audience, but really that's kind of the gist on what happens with pressure when we change the size of the container or volume of the container. And that's really the underlying theme of what we're going to talk about today. So next, what we already talked about measurements. So when we get into the thousandths, and then when we get into the hundredths, what does that mean? So normally, ammunition is produced to a spec, and that spec is relatively important. But as you chamber rounds, so what we have here is kind of a depiction of a feed ramp with the projectile, the bullet, the cartridge. And what happens, especially in a, well, not really especially, but in a semi-automatic pistol, as it's being loaded, the breech face and a spring pushes this into the feed ramp, so there's contact made there, and then it drives up into the chamber, eventually seating within the chamber. So there's contact here, there's contact here as this is being loaded. Now, how that becomes an issue, especially with concealed carriers, is the repeated loading and unloading of a particular cartridge into the chamber of a gun. So we're constantly, or every time we're loading it, applying force to the projectile, which is eventually going to cause it to sneak or creep its way back into the case. Now, once, twice might not be a big deal. Over the course of multiple chamberings, it could cause you problems, and it's worth understanding and knowing why that is. So that's really what we're going to try and do today. We're going to go and do an experiment where I'm going to chamber a round that I've made on my press 10 times to see what that variance is over these chamberings, and hopefully help you understand why that could be problematic. The last thing I'll talk about before we go and do that is really with defensive ammo in particular. You have the normal standard pressure variant, then you have something called plus P or plus pressure, and plus P plus. So the more powder or the more aggressive the combustion within that cartridge, the more apt you are to have an issue as you reduce volume within the case for that action to happen. So normal standard ammunition, you have a pretty mild risk related to this, dependent on how far you've reduced the available area for that combustion to happen. Plus P, you have a relatively moderate risk related to reducing that. And plus P plus, you have a probable risk when you start changing any of the dimensions of these cartridges. It's something just worth thinking about. Now, what I like to do with my own defensive ammo, which is standard pressure, is when I see deviation in the 100ths, anything over like maybe 0.015 or so, I start getting concerned about it, and then I'll probably go ahead and cycle that out. It's just kind of what comes with the ammunition being in use. So it's really a sacrificial anode. I don't try and use the same defensive ammunition for years and years and years and years. Once it's been chambered a couple times, I'll do measurements. I do not expect everyone to do that, but I have the tooling and kind of the background as a reloader to do that. And once I get into that 0.01-ish, 0.015, it's time to cycle out and start from fresh. So that's what you see here. When I'm in the thousandths of deviation, doesn't really bother me so much. When I get into the hundredths, now it's a potential issue and something I need to be cognizant and aware of. So all of this to be said, and we'll reiterate once we're doing the experiment, but you know, all of the ammunition that you buy from a reputable company is going to be tested and have a relatively reasonable pressure spike rate that is known to be safe by the manufacturer. Now, if by our use and things we're doing changes that spec, you run the risk of having a very dangerous pressure spike. If anyone's ever seen like guns that go kaboom, there are issues where maybe there's a blockage of the bore, but another potential causal factor for that is ammunition that has been pushed out of spec by what we're doing to it. It's not always an overcharge or an error at the factory level. It could be something from our mishandling of it when we didn't understand the implications. So by the end of this, I hope I can kind of at least show you guys it's something to watch for. Now, the easiest thing to do is, and I know not everyone has calipers and things like that to do measurements of their ammunition, nor the timer want to do that. But if you see a visual indication where one round is different than the others of the same lot or the same type, it's worth thinking about and it's worth being careful about. Because not only could it hurt or damage your gun, it could hurt or damage you. So with that, let's go to the bench, have a little bit of fun, and let's see what we can make happen with the round, and we'll just go over it from there. All right, folks, so we're at the bench, and what I have is a cartridge I made on my press just to use for demonstration purposes only. No powder, no primer. It's a 147 grain projectile, and the actual length of this as it sits is 1.082. Didn't change the press, and I wasn't loading this, so don't use these numbers as anything as what you should load to, especially with this projectile. I'm just using it only for demonstration purposes. And what we're gonna do is load this up and just chamber it a few times and see what happens to our dimension. So the first one, and again, as we talked about before, as you kind of load this, there's contact going on the bottom of the projectile. Sometimes there's contact going on at the top as it goes into the chamber. Let's just see if it changes anything. So now we are at, so very slight. We'll say about the same. So we'll still use our number, 1.082 for chambering number 1. Oops. Uh, 1.080, so very slight. 1.080. And when I did load this, it is loaded with a crimp. So the crimp is just putting pressure on that mating surface between the cartridge and the bullet, as would be the same with factory ammunition. Chambering number 3. .075. Now we're starting to see a little bit of movement. Number 4. .074. So again, we're still not in real bad territory here. Number 5. .072. Number 6. .071. So again, not huge, but as you can see, as time goes on, that pressure slowly over time has an impact on the depth of that bullet. You gotta get her just right in there. 1.070. Three more, guys, 3 more. 1.069. Again, this isn't scientific, it's just to demonstrate. 1.067. And last one. And we're still 1.067. All right, so let's get this written on the board and we'll just finish up and talk about it. All right, folks, so you got to see we went through 10 chamberings of the same round, and we started at 1.082 and we ended at 1.067. So that was a deviation across these 10 chamberings of a 0.1 or 0.015. And that would meet my criteria for going, hey, maybe I need to start thinking about this round being cycled out or used. So that just gives you an idea. And that was with a very hard crimp from my press. So ammunition can differ. Some ammunition is crimped, some is crimped very lightly. So these are things to think about. There is no, every piece or every manufacturer's ammunition is going to act the same way. This was just for demonstration purposes only. It's not scientific. It's just to show you guys that this does happen with the forces of auto-loading the gun. So again, that for me would trigger it's time to cycle that out. And that could be, I've had ammunition that I saw as much as 0.03, 0.04 and half as many chamberings. So again, that's something you need to kind of understand for yourself and have an idea of the ammunition you run and are you putting yourself at risk. Now, with all of that said, not all, but most manufacturers adhere to SAAMI specifications. And SAAMI is the Sporting Arms Ammunition Manufacturers Institute, which is a voluntary program that most, meaning pretty much all commercial ammunition manufacturers adhere to unless they're making some kind of very special niche kind of round. And this is a system of specs, pressures, and testing methodology that says this ammunition conforms to what to be known as a safe kind of parameter or ballpark. So you could go on and find out different metrics for your ammunition from SAAMI, or the other way to deal with something like this that really I would ask you to do if you are rechambering ammunition or there's something about your ammunition that you don't understand, contact your ammunition manufacturer. They have 100% have technical teams there to ask your questions, and you could simply ask, hey, I'm noticing something different about this piece of ammunition versus another one out of this box. It's been chambered. Is that safe to run, or is it something I need to be concerned about? Or measure it and simply ask them, hey, this round looks to be out of spec, and tell them the truth if you had, loaded it a bunch of times, if that's the issue. But long story short, all of this is kind of to be said. If you're a concealed carrier and you chamber and unload your gun every day, and that happens over time, or you have, a procedure where maybe you cycle them into a magazine somewhere else, over the course of time, you will have an issue with setback. It might be one chambering, it might be 30 chamberings. It's just something to be cognizant of and understand that there's a risk factor there that you are in control of spotting and understanding. So hopefully this was kind of useful for you guys. I kind of had an interesting time thinking about this and how I would set it up and how I would show you without knowing the result. So luckily we got right at the point where I'd start thinking about it. But to tell you guys, if you tested this with some other stuff, you might see very, very different results. And that's okay. because there's so many variables in relation to ammunition and how ammunition is produced. You would almost want to see variations in how it acts, because the OEM manufacturers put a lot of thought, effort, and testing into creating ammunition. And with all of those variables come differing results. But what I will say is this result over time, bullet setback, will happen. It will, if you continue to rechamber rounds. And how you deal with that or choose to mitigate it, it's up to you. It's just something that's out there. So anyway, hopefully this helps, guys. I will see you next time. Appreciate it.